Great, thank you, thank you. So this talk is how to go from data science to data operations. So we'll start off with some introductions, and then just a little bit on like what are some data science challenges? Like what's, and it's really the focus of this talk. And then we'll say, what is data ops? It's a relatively new term. I think the beginning of 2017, no one really used it, except for Andy Palmer originated it from Tamer. But it's really taken off in 2017 and seems to be gaining steam in 2018. And then most of the talk will be the 7 shocking steps on how to do data ops, how you can implement it. And then we'll just have a quick pull it together. And so in this session, I'm going to give a lot of tips. Think about, do I do this? Should I do this? If it seems useful, write it down. And this is a place to learn, and you learn by doing. So say, so as we go through this 45-minute session, think, what can I use and actually do on Monday? Is there one thing, one behavior change I could take and actually put into practice or started to put into practice on Monday? So just keep that in mind as we go through. Please sign in. You could also send me an email. This is gil@datakitchen.io. So thank you, Bernice, for reading my bio. So instead of going over that slide, I'd like to just share with you why I co-founded Data Kitchen. And I met my other co-founders at this company at the end here, Leapfrog RX. And that was a very interesting company. It was like all things analytics. So we had a complete full stack software product that went from ingestion through display of charts and graphs. We had a data science team. We had analysts. We did one-off charts. We did ongoing studies. We did custom software. Like everything related to analytics, we did it. So it was a really great learning experience. And we also all worked for this very challenging boss. He was a Harvard Medical School graduate, and there was this interesting dynamic. And like 3 things happened. And the first was, like any project, we'd say, hey, how long is it going to take? I'd get the question, I'd figure it out, I'd work with my staff, and we'd say, okay, it's going to be 2 months to get this next deliverable. And when we'd say 2 months, he'd say, 2 months? I could do this over the weekend in Excel. That's way too long. So that was the first problem. All right, we're going too slowly. We have to go faster. And then we'd go fast, and there'd be a data error. And our customer would find the data error and call us up and say, this data's wrong. My person looked at it. They're unhappy. You need to fix it right away. It's like, okay, we have to keep quality high. So that's another big lesson we learned. And then everybody wanted their favorite tools. Tableau came out, ClickView, people like Python. It was just lots of tools, lots of languages, and people wanted to use their own. So that's actually the genesis of Data Kitchen, why I want to deliver quickly, but with high quality, and use the tools that I want. So just one slide on Data Kitchen. That's what we enable, delivering fast analytics, high data quality, use your favorite tools, use your favorite data stores. We deliver a software platform that lets you do data ops. And the main features are orchestration of pipelines, deployment to production, and automation of quality. And actually, those last 3 things are really a lot about data ops. All right, so let's talk about data science challenges. So there's this article that came out in 2015, and this picture caught my eye. And they say, if you look at all the code in machine learning systems, right, this one box here is actually machine learning code, right? So I think this is one of the challenges. So this conference focuses a lot on machine learning, algorithms, a little bit of feature extraction, which goes into that. But from a code point of view, there's all this other stuff. And that's what this talk is about, all the other stuff that surrounds data science and machine learning. If we look at it another way, there's a series of steps. If you're doing machine learning, data science, you're focused on building a model, but there's all this other stuff in front of it and behind it. And the green is what we're going to focus on in the talk. And it's a challenge because you might have a model, but you have to do all this other stuff. So if we think about it, there's a business need. You have to prepare data. How many times have you heard 80% of my work is in data prep? Anybody heard that? Yep. So what is data prep? It's a pipeline, right? So a lot of people who are in data science say, yep, I need a pipeline to get the data to me. There's feature extraction. That's another pipeline. There's the focus, building models. But then once the model's built, is it a good model? There's some kind of testing. There's some kind of quality framework, some kind of test that needs to go to say, is it a good model? There's deployment, and that could be many things. And then finally, when the model's in production, is it doing what you expect? And that's like another type of testing. So that's what we'll be focusing on here. And so this picture actually, what bothers me is it looks like a waterfall. So what you need to do is iterate, right? So where you can, look for feedback loops. When you evaluate the model, is it meeting the business need? When it's in production, is it doing it? And then look for opportunities to iterate and have feedback loops as you go through this process, and also go through the whole process several times. So with iteration, comes innovation. Okay, so what is data ops? It's a new term, and we think of it as a combination of these kind of three familiar bubbles on the left, right? So there's Agile, DevOps, and lean manufacturing. So the top bubble is all about people, process, organization, and I have just 2 slides on that. And there's lots of great books, lots of great websites. There's whole seminars devoted to that. The next 2 bubbles are really are supporting Agile. It's a DevOps environment, right? And it's also lean manufacturing, so it's statistical process control. So the technical environment part, we're going to cover that in the 7 steps. And the people, process, and organization we'll cover in just a moment. And those constitute data ops. So Agile, 2 slides on Agile. So the first is, with Agile, there's a lot of people involved. So it's people, process, organization. And the whole Agile movement we see has started with the Agile Manifesto 15 years ago or so. I think it's one of the ugliest websites, but one of the most influential. And if you read it, there's really these 4 values on there. And if you click on the next link, there's 12 principles. And to me, that's what Agile is. I've talked to a lot of people that say, oh yeah, we try to do Agile, but we don't quite do it, right? So it's hard to do effectively in your own organization. But what is Agile? It's a mindset. I think Scrum is a good place to start. There's Kanban, which is good. A lot of places, start with one of those and evolve their own. And it's all about, these 6 things, right? Collaborate with your customers. It's about conversations. The world is going to change, so figure out how to have short feedback loops and iterate. And what's progress? It's not documentation. It's not specs. It's working analytics. So it's, depending on what you do, it's data in a warehouse. It's data in a lake. It's a model in production. It's a graph on somebody's desk. It's working analytics. And in order to do that, release frequently, chop your work into small pieces, and work on the most important thing first. And when you release a small piece, get feedback. And then finally, so number 5 is focusing on improving the work that you produce. And number 6, adjust behavior. Look at your whole process and fix that as well. And then one thing is, if I could give everybody one piece of advice, it's focus on value. So as you're doing your work, know who your customer is, right? If you're a data engineer, you're probably producing data sets for a data scientist or a data analyst. Focus on them. If you're a data analyst, you're producing a chart for someone in marketing focus on making them successful, deliver value. Similarly with models, deliver value. And then think about your overall context and your business context as well. There's a professor here in the Boston area, Tom Davenport, that talks about data offense and data defense. So think about your business context. And I like this model. Data defense is making sure you don't get into trouble, right? Am I compliant? Is quality high? Am I audit ready? Right? Those are important projects. And data offense is contributing to the top line. Am I bringing in more revenue? Am I bringing in more customers? So think about what your project is related to the top line, and always think, as what I'm doing, am I delivering value to the whole company, and am I delivering value to the person who's next in the chain? All right, so that's the introduction, that's the context, and if you remember, let's just look. So we're going to be thinking. So think about this picture as we go through the 7 steps to data operations. And before I go on, any questions or comments so far? Okay. All right, so here they are. Here's the 7 steps to implement data ops, and we'll be going through all 7. So the first is orchestrating 2 journeys. Right? There's 2 pipelines. We'll talk about that. The next is very simple. Add tests. All data work should have tests of some type. Some do, some don't. Use a version control system like Git or something else. Then you could branch and merge. You need environments in order to support your branching and merging. And then, reuse and containerize, and finally parameterize your processing. So here we go. So the first, orchestrate 2 journeys. What's the first journey? Orchestrate from data to customer value. So a lot of people call this a data pipeline. It's a series of steps that takes raw data, starting maybe in the origin from an operational system, from a public website, from a vendor, taking that, transforming it so it's fit for purpose, and then actually getting value out of it through either a chart or graph or a model. And it's really, we see this as a series of steps. And this kind of view, it's like an assembly line, like a car assembly line. And you should treat it like a car assembly line. You want to make sure things coming in are high quality. That's where tests come in. We'll talk a lot about that. And each step, things are going according to plan. And actually, this is where the name Data Kitchen came from. We were thinking of calling it Data Factory. But then why not Data Factory? Well, when you're at a party, what room does everybody kind of end up in? Everyone's in the kitchen. So we thought it would be more fun to work at Data Kitchen instead of Data Factory. And also kitchen is fun because you get to use the analogy of there's raw data, which is like raw ingredients. There's prep. You combine it. And then out comes a nice serving of insight. So the second journey is speeding ideas into production. So you have this pipeline, this value. We call it the value pipeline. It's a data pipeline, and you need to iterate. So therefore, you need to make changes to it. So the second thing to automate is having an idea. In software, it's called a feature. In data science, a feature is something else. So we call it an idea, and we call this the innovation pipeline, where you want to get your ideas, which can be implemented in a number of tools, a number of people involved, and you want to get that into production. So it's really like a software development process. And that's what we think data ops is about. So in the software world, first there was waterfall, then there was agile, then there's DevOps, and releases went from every 12 months, every week. Now Amazon releases multiple times a second. How? It's an environment where this process is automated. And that's how we should think about data and data there. So, and this is where you want to implement each iteration. And you want to do both of these together. So there's two automation focuses, from raw data to value, and then new ideas, getting them into production. And when you do both, you want to focus on quality, like a manufacturing line. Quality when you bring things in, so when you deploy into production, you don't break anything. And then quality as data flows through, so your end customers don't call you up on Saturday morning and say, hey, something's broken, you got to fix it. You want to avoid that call. So step number 2, add tests. So how did the software community go from delivering from every year to multiple times a second? Automation, and it's all about tests. And with tests, on the innovation pipeline, it's a way for a developer or modeler or analyst to say, I'm going to make a change, I will run my tests, and I could be confident I'm not going to break something when it goes into production. Similarly, you need tests on the value pipeline, so as data flows through, you can detect errors and do something about them. So where do those tests go? You could think of them in each step as putting them into these 3 broad categories. As data comes in, is it free from issues? Is your business logic correct, right? So as you're doing your data work, maybe you're assembling things, maybe you're doing integration, you have certain assumptions in your head. Each assumption should be a test. So if that assumption is no longer true, you could know about it and not have your customer find it. And then finally, are your outputs consistent? We think of these as the Hubble telescope test. So if you remember the Hubble telescope, it was this great telescope. It was in a satellite. And what happened? The images were blurry. So they had to fly up another shuttle and install a contact lens, like a big lens to fix it. And I'm sure it's not this simple, but I'm thinking, did anyone look through it first and just see if it worked? Right? So there's a simple, so the same thing, when your analytics are out, just have some sanity tests on your outputs to make sure it's working.
1 second, sir.
What's that?
It's 1 second, sir. So
yeah.
More people that are still down to this session, they are kind of stuck behind. So I'm trying to see if there's a bit of room that we can do some stuff. So do anyone have chairs beside them? Anything? You want to make the them on the back? Also, on the front, on the side, if someone wants to sit down, that's totally fine. Yeah, so people that remain outside can get
Is it okay if people sit along the front here? Yeah, there's plenty of floor space right here. And anybody sitting next to an empty seat, raise your hand. So empty seats?
Problems are being popular.
Yeah, so keep your hand up. We'll just take a pause here. And this reminds me of my subway ride coming in here. Oh, the bus driver didn't ask us to put our hands up to find some seat. There's two more up here. All right. All right, so there's lots of tests, right? So this prevents the Saturday morning call when you're at soccer or with your kids, or you're trying to sleep late, that says, hey, the data's wrong, right? Tests are your friends, right? Because with any data pipeline, it's not will something go wrong, but when will something go wrong? So, and when something goes wrong, you want to, the next thing is, what do you do, right? So if it's really bad, like the Toyota line, this is in contrast to American manufacturing in the 80s. In Toyota, they said if something's wrong, everybody could pull something and just stop the line, right? And that was actually the opposite of what American companies did. They said, no, we can't have people stop the line, it'll never go. But if something's bad, stop the line, investigate. It's better to not deliver something than to deliver something's wrong, because then you lose trust with the people you're trying to serve, right? So tests are all about trust. Or it could be a warning, you investigate later, it goes into a release note, or just info where you come back. And you could make process control graphs on your tests to make sure things are within bounds. And that's our tie into lean manufacturing. And here's like a bunch of examples of tests that you could put in. So you could read these off the slide, or I could send it to you. But what's a good way to start with testing, right? It's a multi-step process, and in every step, put at least one test, right? Just try to think of something, put it in, and you'll say, oh, this will never fire. But it does. And every test that fires and warns you about something is your friend. And then when the trust is sufficiently there and your users know, hey, there's hundreds or thousands of tests being run on the pipeline as data is being produced, if you do miss something, you could say, oops, sorry about that. Thank you for finding it. I'll add a test, and then it'll never happen again. So in an agile fashion, do the best you can, get some coverage, and then iterate. Your tests are really never done. Here's some very simple example of tests. So what's a data test? I think one of the most simple and standard is just looking at row counts, right? If you're pulling a customer database, it's going through a number of processes. All right, I've got a million, a million, a million, a million. 50,000? Something happened. Or there's a bad cross join. I got a million, a million, a million, 100 million. That's not good either. If you pull customers, sometimes you expect it to just grow over time, and if it doesn't, that's worth the conversation. So we've seen that. We say, our customer list has gone down. There's a conversation. Say, oh yeah, we cleaned up the CRM and got rid of a lot of duplicates. Okay, no problem. But it couldn't. Other times when it went down, it's like, whoops, there was a problem in there. And then just other things. So anything that's gone wrong is a good candidate for a test. And it could be a lot more sophisticated than that. You can look at the sum of sales broken out by territory, and compare that to the last load. So it's really form follows function. Okay, and then so this is the last one is getting things into production, right? So the tests, if you remember, serve two purposes. On the innovation pipeline, on the value pipeline, it makes sure data quality is high. On the innovation pipeline, it makes sure when you make a change, you don't break things. So has anybody heard after production break, oh, it was just a one-line change, right? You don't want to hope. You don't want to make a change and say, oh, I hope this works in production. You want to know it's going to work in production. And tests are your friends here. So, just following a common software development pattern, you make your change, run all the tests. When all the tests work, then you can deploy or promote into production. And you want to automate that deploy. All right, so testing is important. That was step number 2, and I wanted to give it a good amount of time because it's, I think, one of the more important steps. So remember, can you use any of this Monday? If you can, write a note to yourself. Okay, this one is pretty straightforward. So there's a whole bunch of tools, right? There could be Python, SQL, R, even Tableau notebooks, Excel. We see it all as they all produce code, right? Some of the code is more code-like than others, right? So SQL is really code, Python is code. Is an Excel notebook code? Well, it's an ASCII file, but whatever it is, put it in a source code control system. So that's step number 3. And once you do that, you could then branch and merge, right? So that way you have a place where you could work on your own stuff, right? So you can't really see that laser, right? So the main line going through is it's labeled development, but you can think of it as what's in production. If you have a work to do, you make a branch. It's a place to make your changes without affecting other people or other people affecting you. And then when you're sure it's good, how do you know it's good? Through tests. You could then merge back. So here's if we think of Agile and we think of Scrum for a minute, here's an example pattern of branching and merging where you have the main, or sometimes it's called master, sometimes it's called the trunk. That's when it's in production. This is a common pattern where you have a sprint for the week. You then make a branch for that. Every feature, that's the box, feature 1, feature 2, feature 3, feature 5, those each can have their own branch. You merge back to the main trunk at the end of each sprint. If anything is not complete, you move it to sprint 2. And this is a way to move fast and not break things. Now with each branch, you need a place to run things. And this is where it gets tricky with data. Right? So in software, you could make a branch, you could run it on your computer, and that's your whole environment. You could carry it around with you. It's really not a lot of stuff. It may be complex, but it's not big. But with data, this could be a gigabyte, a terabyte, a petabyte. So that's one of the challenges. So when you have a place to work, when this pipeline runs, it runs on a set of equipment. We call that an environment. And when you do your branches, you want to be able to create an environment to do your work that's separate from production, right? And so a couple things on that. So why? If you're a data scientist or analyst, let's say you're a data scientist, you're working on a model. It could be really confusing if you're trying to refine the model and every day the data is being refreshed, right? So did my model improve? Did my model get worse? Or is it just the new data from that day or hour? So you want to hold your data constant. Similarly, if you're building a new feature, it's not good to work on production because you can make a mistake and bring down production. That's not a good outcome either. So you want to isolate your code, isolate your environment, and there's two techniques to make the environments. One is a more traditional one. Companies have like a dev area, a QA area, maybe a stage area in production, where those are set up and run. So each branch, there could be a branch associated each with those static environments. That's one technique. Another is if you're using the cloud, there's a lot of power where you can actually just spin up and use temporarily a whole environment. People talk about big data, but from our experience, the cloud has enough power to spin up an environment that has all the data for your particular need. Right? You might not need 10 or 20 years worth of data, but if your model's working on the last year of data, that's an environment that could just be spun up and used and then thrown away. So what we see is a way to move quickly and actually save some money too is have one production system and then have development environments that come and go based on the project or the feature. And those T's you saw, I just want to kind of tie it. The two journeys, right? The value pipeline is what's running in production, and that innovation pipeline is really just a branch plus an environment where you can iterate and get things into production. All right, now on to step 6. And step 6 is kind of a triple, right? We want to keep it to 7 steps. So this one's a little overloaded. So reuse and containerize, right? So in software, so you could probably guess this talk is saying, well, my background is in software development. I've been a lot of my career was a VP of engineering at different startup companies around here in Boston. And one thing that to get speed is reuse code, right? Create a library And actually, as a data scientist with Python and R, there's so many libraries out there available to do the job. So reuse of code in your data pipelines or your modeling is an important step to go faster. Another thing is what's the output of one pipeline. One ingredient could be the output of a pipeline could be the input to the next one. And it's actually kind of a nice food metaphor. If you buy a bottle of salad dressing, that's the output of somebody else's recipe, and then you could use it in your own recipe, like to make chicken. So the data is something that can be reused, and you want to develop a system where if the ingredient is fresh, right? Do I need to rerun the pipeline to generate that data again, or can I just use it as is right off the shelf? So look for ways to reuse your code and reuse your data. The second thing is containerization. And this is actually a very powerful way to enable teams to go faster and with high quality. So the first is environment control. So you want to make sure that the environment that you're doing your development in matches what's in production. And what's a good way to do that? Some type of container or virtual machine environment. So when you do the deploy, if you could have a container that has everything you need, it works through testing, you put it out in production, that will help reduce errors as well. And actually, there's one other kind of concept in here, which is in your data pipeline. Right. So you have things run. Actually, I think we're good. That we're good on that one. And the last shocking step is parameters, right? So if you think of your pipeline like a big function, this can help you move faster and reduce errors. So parameters are a way to, you could have sets of parameters, and with them you could vary your inputs, your outputs. You could just use them to control how many steps in your pipeline are executed. And I think one interesting example, I take it from the pharmaceutical marketing area, is they'll buy data, right? They'll buy sales data for a particular market for a particular drug. And what's interesting is it's not complete data, so there's a data scientist somewhere doing a projection to say, well, based on this sample, I'm gonna model the rest of the market. And then that's used to inform decisions in sales. So that's the scenario. And what happens is these suppliers of that data say, you know what? We have a better model. We're going to change our projection. So if you're basing salesperson's compensation on that model, you don't want to just put the new one in and kind of hope for the best. Because if their territory goes down for some reason, there's going to be some surprise people. So through parameters, you can support that scenario. So if your input, let's say, is in an S3 bucket, you can have a parameter that points to another bucket. And if your output's going to, let's say, a Redshift database, you can have a parameter that points to a different Redshift database. And then the code is completely the same. So by changing the inputs, the outputs, reusing the code, you could have two systems running in parallel. You could make comparisons, and then you could be proactive with your customers and say, hey, here's the difference in territories due to the projection. I think I'll go talk to the sales management and see how we want to handle this versus just bringing it on them. So let's just pull this together now. Right? So that's the 7 shocking steps. And let's come back to this picture. Right? So we start with a business need. We're preparing data, feature extraction, building a model, evaluating, deploying, and monitoring. So how do these 7 steps apply to each of this kind of simplified model building example? So I'm going to take each step here, put it as and that's in the first column. And then each of the 7 steps is across the top. And this is just one view. And this would be a good exercise for you to do in your own environment. So let me just go through the the modeling steps and say how they apply. So the business need, I think that's actually is not the 7 steps, but that's one of the agile ideas of focus on business value, focus on your customer, have a conversation. Now, prepping data, that's a model. I'm sorry, that's a pipeline. And I think it could cover, you could say maybe it doesn't cover all of the 7 steps, but if there's a pipeline, it's in production, you want to change it. You should put it in version control. You want to branch and merge when you make the changes. When you're making an update, you need an environment for it. Hey, it could be reusable. And then finally, it's always good to parameterize. And likewise, feature extraction's a pipeline. Building the model, I think it should also follow each. And deployment, the same pattern. I think the evaluation of the model and monitoring the model when they're in production is really a testing task. When you have a model, how do you know it's good? And you're going to iterate on your model, how do you know you made it better and not worse? You need a test for that. And finally, when it's in production, how do you know that it's not drifting and getting worse? So you need a test for that as well. So that's the 7 steps to data ops as it relates to data scientists, data science. And make a note to yourself, from what you've heard, is there anything that you can use on Monday? So with that, let me open it up to any questions. Oh, thank you. You run the. So I'll either repeat the question, or you could hand out the mic in the back.
Thank you, Gil.
My question is about the testing. Usually, Agile it's about getting quick feedback, having like quick tests, like any kind of tests. And because in Agile or in software, we use like kilobytes of data for testing. How we do it for data softwares with terabytes of data, how can the test be fast and quick?
So a question on testing. I think everybody heard that. So it depends on what you're doing and your domain. So if you're lucky, your test, the data you're working on is small enough and your compute is fast enough so you could just run the pipeline on the entire data set, right? So that's one case. It's not always that way. So then there's actually, like any test, it takes some work and you need to craft a data set to match the code. And you can then, there's a step of making a small or making a sample of your data set so you can then have different levels. So you could have kind of like a unit test data set where it's small, it's fast. You could have like a medium where it's a little slower to run, and then you could run it across the whole thing. And still, if the whole thing is too big, sometimes production is just too big compared to what your test. You still need to sample and craft something. So it takes, there's nothing free here. It takes crafting.
Thank you, Gil.
You're
Any
welcome.
further questions?
Question, yep, up front.
I noticed you mentioned Docker. For those of us, including myself, who don't know exactly what Docker is in terms of containerizing, can you just give us a brief little?
So what is Docker? You could think of it as a very lightweight, as a complete machine, right? So the trend is you have hardware, you have virtual machines, and you have containers. But the idea is it's a complete environment to run some set of software. Down in front.
When you mention the data reuse in the development process, do you mean loading the data in a Docker image because it's immutable, so you can reuse it again and again?
Yeah. So for the data, do I mean putting it in a Docker image? Now, I would keep the data separate. I would have the data organized somewhere else, actually a lake of your your choice. And when I say a lake, I don't mean Hadoop. It could be Hadoop, but it could be S3. It could be a file system. But I think the data should be separate, and there should be a clear path to it, so you could version it with the path to the data.
You mentioned that your dev environment should match your production environment, and if you're lucky, you can run tests on the actual data set.
That's right.
How do you deal with pulling production data into a development environment where there might be restrictions on some of the fields in the data or sensitive information?
Right. So, right. If you're lucky, you can pull production into dev and use that as your set. If not, it's work to craft it. So if there's something sensitive like a social security number, can you have another pipe? Here's an opportunity for another pipeline that takes it and maps real social securities to fake ones, or obfuscates it and just has random numbers on it. So you have to do the work of crafting a data set. And that's one. And that is the big difference between software. DevOps and data ops, I think, is that there's this big data set you also have to contend with. But that's the IP, that's the value. It's extra work, but having tests really pays for itself. It's an investment that's worth it. I think we have time for one more question before we lose the room. All right, I think we're set. Okay, thanks everybody. Appreciate it.
Thank you. Thank you, Gil.